Now the next topic is template. This is the most important topic in C++. Templates are used for generic programming. The generalization is based on the data type. So you can write down the code which can work for any type of data. Already I have shown you template function. That same example I have taken, the maximum, which will find out the maximum of two integers. Suppose I want to make this work for any type of data, then I can say template class T, and instead of integer I can use a T here. So the same function can work for finding maximum of two integers or maximum of two floats or doubles or characters, any two things. It can find the maximum of any primitive data type. So you can pass any primitive type or any user defined classes or structures. You can pass any type of thing as long as it can be compared. If you want your own classes to be passed and you want this function to find maximum of 2, then in your class you must override this operator, that is greater than operator. You should provide the functionality to know which object is greater, then this function will work for your classes also. Then next, let us take an example of a function where we can pass multiple type of arguments. I'll remove this. I'll take one example function, just a simple function, template. Now here I will give a class T and also class R. Two classes are there. Now function takes two values. Let us say add is the function name, which will take T type variable X and R type variable Y. And a simple code I am writing here which will add X and Y and display the result. That's all. Now this function I can call it by passing one value as integer and the other value as double. So one value is integer, other value is double. So this T will become integer type and this R will become double type depending on the values that we are passing. First value is integer type, so T becomes integer and this becomes double. So even we can have multiple parameters in templates. If required, you can use multiple data types also. Now next I'll explain template classes. Now let us look at template class. So for that I have taken an example class stack. I guess you already know what is a stack. It's a data structure. So for a stack, if I am writing a class and I am implementing a stack using array. So for implementing a stack, I have taken an array, that is array of size 10, okay, whose name is S. And also I have a top pointer to point on a particular index. So initially, mostly we know that top pointer will be at -1. So I have an array and a top pointer. Then I have function for pushing a value into the stack and I have a function for popping a value from the stack. So briefly about the class I have explained you, that is stack. I don't want to explain everything about stack. Just briefly I told you. Now if you look at this, this is a stack using integer. This is only for integer. This will not work for float type of data or a character type of data or a string type of data. It will not work for any other type. So this is an integer stack. Now the problem is, suppose I want a float stack. Then I should write another class. If I want a string stack, so here the strings should be pushed and pop, then I should have a separate class. So instead of writing many classes for different data types, you can write a single class for all data types. How? I can make the class as a template. Let us see how to make it as a template. So here on the top, say template, inside angular brackets, say class T. So I am defining a class called T, which is of type template. Now, what should be template here? This array should be template. What about top pointer? It's an integer value only, so that need not be changed. It's an integer only. Then push function. It should take a value and push. Which type of value? Whatever the type of array is. So it depends on the type of stack or an array. Then pop function. Pop will pop out a value and returns the value. So what type of value it should return? It depends on the type of a stack or an array you are having. So this also should be T. Then I will also show you how to implement these functions. I have written only the declaration of the function, then their body should be written outside. How to write that body, let us see. Now I am writing void push function. Void push function belongs to a class stack. Yes, stack. And scope resolution. And the function name is push. And it takes template X. Now, this is outside the class. There is no space here, so I am writing here. Okay, this is outside the class. Then for this also I must write template. Template class T. So that same T is used here. Now one more thing. Class is which type? It's a template type. So whenever you write the class name, you must write a template parameter here. Then write down whatever the code for push function is. This I will show you by writing the code. Then I have to write on pop function. So for pop function also say template class T. Its return type is T. Then say stack, and whenever you are using class name you must pass a template parameter, and the function name is pop, and here you write on the code for pop. That's it. So I have implemented both the functions. So for implementing each function, when it is done outside, you have to give template every time. But the syntax I have shown you. For class we have to write template, and again for every function when you are implementing outside using scope resolution, you must use template. If I am creating an object of this stack class, let us see here. I will say stack S. What is the data type? I have to say integer. Now this is integer stack. Now again say stack and say float and say S2. Now this is a float stack. Float stack. Like this you can mention the data type and you can convert this class into that data type. So everything wherever T is written it becomes float. So this is a float stack. Push will take a float value, pop will return a float value, everything is float, and the array is a float, everything is float. So this is the benefit of templates, and this is more powerful feature. This will reduce the work of programmer. Makes programming lot easy, right? And this feature is available in Java also, where you cannot define your own template classes, but built-in template classes are there, you can use them. But in C++ we can define our own classes and functions of type template, that is generic data type. I will write the complete program and show you.